Hey everyone. So what I wanted to do today, I'm doing some preparations for the upcoming 2R3E solution from Hydros Plus, and I had to go ahead and take off the stock pump. Still waiting on my prototype, but there's some work that I can do ahead of time. And while I had this out, I thought I would just crack it open and show you all what's inside. It's a little different than the 1 Series pump in that this has two separate pumps in one unit that handle implements for this pump, which is an 8cc pump, and this one is a 6cc pump that handles the steering. Other differences are the spur gear here, based on how this connects to the 2R3E series tractor. It's actually going to use this larger gear, but it's still a one-to-one with the engine. So at 2,500 RPMs, engine RPMs, this pump is running at 2,500 RPMs as well. And that's good, and it's been consistent on every tractor that I've seen, but it definitely makes the calculations a lot easier. So, you know, it is possible, certainly, for them to gear this in a different way and say, make this a 16cc pump and gear this down 2-to-1 or 1-to-2, depending on how you look at it. But as an end user like myself, I'd have to do a lot more research to kind of confirm those different ratios. So that's a plus. The other plus I'll point out is the fact that this is a spur gear. Now, if you've been inside of a diesel engine, specifically a Yanmar, you're going to see gears like this for timing and other things, but they're typically helical. And the reason they're helical is because those are generally smoother and quieter. And not to say backlash doesn't matter with a spur gear, meaning, and a spur gear, if you don't know, is just having straight teeth versus the kind of angled teeth. It's going to be a lot, there's basically no worries around backlash. And what I mean by that is it's kind of only going to go on one way. There are no adjustments. So with this particular unit, you can see it has a collar here with this O-ring, and this O-ring is not really holding any pressure. It's just basically keeping it from being metal to metal so that any oil that's splashed up on here doesn't leak out. But this is what is going to center it. There's no adjustments. And then you'll see when I pull this gear off, this is on a taper. That's machined at the manufacturer. Sorry, I'll show it to you better when I pull this off. It's machined at the manufacturer. Whether you put the 37 foot-pounds, which is what it calls for on this particular gear on this nut, whether you put 15 or 150, your variance in how far this goes on is going to be tenths, if not hundredths of a millimeter. So I'm mentioning that because you know, there is a backlash measurement for this platform in this particular unit, which is 4 thousandths to 8 thousandths. But there's absolutely no way to adjust it. And the reason they don't call out how to adjust it effectively is there are no adjustments. And based on the way they've built this, if these are built to spec, you should have no issues. Now, a couple things I will mention. You've got two, you know, we talked about having two pumps here. You've got two pressure side outlets, but you have one low pressure inlet. And in this case, it's 1.25 inches or 32 millimeters, and it's going to route oil, low pressure oil, to both of these. And I'll show you how it does that once we get in. So let me go ahead and buzz this off. Try to hold it up so I don't. And when I took this off initially, it didn't take a lot of pressure, but it did pop a little. It took a little bit more pressure. Now for this gear, and if you do get this solution, you are going to reuse the gear that's on your tractor, which I think is actually better because it's already meshed to your gear set and already broken in. So what you're going to need here, this is a 3-jaw puller. You can get one of these for 20 bucks at most auto parts stores and Harbor Freight for sure. You can spend as much as probably a couple hundred. I think I saw one that was almost 200, but there's no reason to do that. If you're only going to use it for this application, just go get one from AutoZone O'Reilly's. They rent them for free, effectively. And the ones you get are typically higher quality than the $20 version, but you don't need a high quality for this. all I'm going to do is align these jaws. And when you do get your gear puller, whether you rent it or you buy it, this may come off real easy, we'll see. For this particular application, you'll have 2 holes here, and you can actually reverse these for longer pulls. This one is one of the shortest ones you'll do, so go ahead and use the short side of these. Let's see if I can probably pull this off. Since I've already had it off, probably pull it off just with the wrench. There we go. So when I pulled it off initially, because I hadn't had this on super tight, and you know, it hasn't been on for any amount of time, just a couple of hits with the smaller impact that I have. I think it's 150 foot-pounds, this max, and it popped right off. Let's put this gear to the side, O-ring here, we'll put it there, and let's buzz off these back bolts. Hopefully the camera's not shaking too much because I've got it hooked into my pick this up. All right, it's got 4 long hex bolts going all the way through. And as we pull the cap off here, you're going to see what you see in a typical gear pump. You've got some O-ring, and sometimes those O-rings are in the back plate, but for this particular brand, they put them into the housing. You've got bushings that are visible, and then you've got this, this seal towards the pressure side. The humps are towards the pressure side here with the backing ring. So let's pull off the steering portion of the pump. See what we see. So typical gear pump, if you saw my other video with the 1 series, or if you've seen pretty much any YouTube gear pump video, this is what you're going to see. You're going to see bushings, and uh-oh, broke it. This doesn't matter as far as breaking it because it's just a backing ring. The actual sealing comes here in the in this gasket here. I think this is probably nitrile. So that was very brittle, but you can pull those off if you want. Probably pull the backing ring off would be ideal. And then just as a reminder, if those of you who are less familiar, you know, you've got your gears in the middle, and you've got your, in this case, the suction side is here, because if you remember, rather than it being like this one where it goes straight into the pump housing, it's actually got to come through from here, and it's routed towards the back. So as it makes its way here on this side, on the low pressure side, it's actually going to turn in this direction, and the fluid will travel around this way and then be pressurized in this little area here and come out here. You know, I think that most people, when they see it at a glance, think it works this way, where the fluid is pushed through the middle, and that's not the case. The fluid actually can't really make its way through the middle. So the other thing I'll mention, well, I've got you, and I don't know if I can, right, you see right here, it's going to focus. There's a relief that's cut in this. This is like a brass or copper bushing. It's probably not copper, it's some type of softer metal though. And they cut this relief. And this is in all of the bushings. And the reason it's in there is when you put it, that's the wrong direction, but for purposes here, you can see, get my pointer, right there is a gap between the shaft here and the bearing so that fluid can come up through it. And that fluid comes up through it on the low pressure side. If I had it right, it would be on this side. Or the high pressure, yeah, no, low pressure side. So it comes up through here and it can circulate and come back into this low pressure side and be used again. So that's general operation. Got a broken backer ring here. All those backer rings are identical in size and function, at least for these same pumps. And I've had a few different pumps apart. They all look very similar, but I haven't tried to see if they actually work. So that's let's do this, and if I have good enough skills, I will do a picture-in-picture and do a calculation on what this actually is. So make sure I'm zeroed out here. I've got a zeroed micrometer, and the width of these is 9, I suspect, okay, 955, right? So 955, and by taking these measurements, we'll be able to, let me do the other measurement here. So 955 on the width, trying to make this is, so I would say 37.9 probably. That's the biggest it gets there. And this, well, this is not the right, tool for this job. See if I can get the smallest measurement here. I have a feeling that the spec's probably 69.5, but we are at 69.58. I think it's the smallest one I saw, so 6.9. For the record, I can do picture-in-picture. Actually, I had it pulled off, but as a part of the editing process, I realized that I had one measurement that wasn't right. And so rather than put those up in picture-in-picture and have you ask additional questions based on, what I said the displacements were and what we were getting in these calculations, I thought I'd just pull you out here to the browser, bring up a couple of tools, and give you some inside baseball on the process of how, I realized that I wasn't correct, and some of the tools I used to verify things. So to orient you here, I'm just using this Mataris site that has a cubic displacement calculator. You can find a number of these out there, as well as you can just do the math on pencil and paper if you'd like. They provide the calculation here if you want to do that. I'm using Google as a CC to CI conversion, so I need that because I use Womack's engineering toolbox in a lot of cases to determine flow rates, and they have all types of calculators, torque, pressure, etc. So I really like their site, but I don't think they have a cubic displacement calculator. I haven't found it on their site, so I'm going to go ahead and use Mataris. And I have a couple of videos that I looked back at to verify that my thinking was correct. So let me jump back over here to the Mataris site, and what you just saw me say was 955, and this is in millimeters, a geared diameter of 37.9, and a bore-to-bore, which is, you can see here, that last measurement I took, I measured as 69.5. Now when I ran this calculation, and this is for the power steering pump, I got 5.7. It's 0.3 of a cc off. That's pretty far off for what I've seen in different gear pumps. When they say they're an 8cc, I do these calculations. It's, 7.9 or 8.1. It's pretty close. This didn't seem close enough. Now, you haven't seen it yet, but when I go to the implement pump, which I have a little more information on because I've actually done a flow meter test on, it's actually 12.85. So I put 12.85. These other values are the same, and I do the calculation, and it's 7674 or 7.67 cubic centimeters. Now, that immediately sparks a thought for me, because I was like, wait, when I got the 12.85, I thought to myself, I think that's exactly the same as the 1 series pump. So I went back to the video and checked. 12.882. So we say 12.82. 12.82, 12.85, that's pretty close. The other piece of information I had is I had done on this exact pump a flow meter test. And at wide open throttle, 2,700 RPM is what I'm going to use. We're assuming some accuracy on this tachometer, but here's what happened that day. 2650, almost 2700. Looks like you can get about 6.1, maybe 6. 6.1, I said maybe 6.15. You know, I don't have the granularity here. So a little over 6 is basically what we can say. So the fact that I know that the 1 Series pump is an 8.2 cc pump, and it has the same gear width, which with the same other dimensions, and the fact that this tractor is getting 6.1 based on my tools, I can actually go over to Womack and they have a displacement needed for GPM. So if I say 6.1 gallons per minute, 2,700 RPMs, it says I'm going to need a 0.52 cubic inch pump. Do my conversion here, 0.52. Says it's an 8.5 cc pump. So all of that is pointing to the fact that my calculation here at 7.6 probably isn't right. So knowing that, I went back down to not only this pump, but some other pumps that are made by the same manufacturer. And I actually took the gears and measured those on the outside, and then I remeasured the inside. And what I came up with was like 69.01. So I'm just going to say 69 in this case. I guess I can put the 01 on here. I'll do the calculation, and it's 8.143. So that's in cc, or that's cubic millimeters, so 8.143 cc's. Do that transition, 8.143, 49.69. Call it 49.7. So 2,700 RPMs using this pump flow in gallons per minute at a 0.497. You're going to get 5.81 gallons per minute. Now, I realize this still isn't the 6.1 that I measured. There are other factors that can, make some of that variability, as well as my tools may not be, their margin of error. I haven't looked it up, but I'm not sure what the exact margin of error is on my particular flow meter. But this starts to pass the sniff test. It's similar to the 1 Series pump, similar to what I got when I measured it in the real world. So that is the measurement that I got wrong, and I wanted to correct that so it's less confusing. But unfortunately, it's probably made the video just a little bit longer. So without further ado, back to your regularly scheduled programming. So here's our spacer here. Oh, here we've got a connector, and that's really the reason for this spacer, because I think it makes the machining easier. But effectively what you have is a coupler here, and because you have that coupler, you need the space for the coupler, you have to have this spacer. Otherwise you'd have to machine this in such a way that they could work together, and that probably is a lot tougher than what they've done here. Let's see. Spacer, well, I'll point. This is where the coupler goes, and this is where the fluid comes in from the low pressure side into the larger, or the steering pump. Come on. Act like you've been apart. Well, all right. So this comes apart the same way. Same type of thing, 2 bushings, 2 gears, one without an input and one with an input. And this is the face plate here. So put these to the side. This seal is not high pressure, but if this were a motor, and it can be used as a motor, but if this was designed for a motor, this would be higher pressure seal. But as it is, it's simply a flat plate, and this is where the input shaft comes through to engage with the engine. So let's put this over here. So same principle, but much longer piece of steel here. This is 14 splines, which is different than the 1 Series. This is 14. It is, the 1 Series is a 12 spline. They're probably both proprietary. It's 15, roughly 15 and a half major dimension. But, let's do this. So I'll try to do another picture-in-picture. If not, which I probably won't be able to figure it out, but if I can't, I'll just put the calculation down below. 12 point, interesting, 12.85, 12.85. So I'm humming because this is supposed to be an 8 cc, and this one, the power steering, is 6 cc. In the dimensions as far as the size of this gear, as well as the dimension of this opening, is this basically the exact same as the 1 series pump. What's curious is, I may not be remembering it right, but the 8.2 cc, 12.85, 8.2 cc 1 series pump, I think has, I thought it was like 12.8, which means one of two things: that this is actually a little more than 8, or that the 1 series, at least the one that I measured, is a little less than 8.2. My guess is that this is a little more, and we'll see in the calculation. And the reason I say that is I got, even at 2,500 RPMs, which is what it's measured at, you know, and they said 5.3, I think I got like 5.7 or something more. And so it's a little bit tricky because it starts to make you question your equipment. Pump that is similar in dimensions here, but you're going to have gears that are a little bit wider on the implement side. And right now, the calculations, if everything comes out the way it's supposed to, show that we'll be over 10 gallons a minute, you know, starting from a spec of about 5.3, I'll say 5.5 to 6 is what I'll say. As in a stock spec, we're looking at 10 to 11. I don't know where it's going to fall in there, but I think it's going to be more than 10. So hope this is interesting. You know, again, not something that you need to know for the solution that is coming in the next week or so, and this is early January 2022. If you're watching this later, that solution is probably already available, so come visit hydrosplus.com and have a look at what we have to offer for the large frame 2R and the 3E series. And one last thing I'll mention is this goes down to the 3025. I know that the 1025 and 2025 are also 25 horsepower tractors, but the 3025 has a larger displacement engine. It runs at lower RPMs, and it's built on this platform. So if you have the 3025, this is for you as well. Come have a look at hydrosplus.com. Thanks for watching.